Okay, YouTube, in my last video we discussed combinations of n total elements taken r at a time, okay, and we familiarized ourselves with this formula over here, but essentially what this said was if you know how many total objects there are and you want to know how many ways exist to choose, say, r of them at a time in order, doesn't matter, okay, so order doesn't matter here. Then we'll use a combination to begin with, okay. So what I'm going to do is I'm going to run through a couple examples here where we will use combinations, but what we're going to do is we're going to use this kind of in conjunction with our fundamental counting principle or multiplication rule. So let's go ahead and start by reading this first example. This is very common. You'll see these often. It says, consider forming a team of 12 people from 10 girls and 15 boys. And so hopefully, alarm bells are going off already. You're not going to be able to use all the girls and all the boys to make a 12-person team. That'd be 25 people. So it says the team must consist of 5 girls and 7 boys. And so let's look at the question here. Well, always the last sentence is usually the question. It says, how many different 12-member teams are there possible here? Okay. So here's how this is going to play out for you. I'll kind of take you through this example. What we're going to do is this. We say the number of ways that we could choose 5 girls from. And we have, looks like 10 total girls. So 10 girls. Okay. What we're going to do is this. We're going to choose a girl, our girls first, and then we'll choose our guys. So essentially what we're doing is we're using our fundamental counting principle where we say, what we could do is we could go find the number of ways of choosing 5 girls from 10 girls. And then what we could do is we could go find the number of ways that we could choose. Looks like we need 7 boys. So 7 number of ways to choose 7 boys from 15 boys. Okay. So what we'll do is we'll find these individually and we'll multiply them together. So I'm going to kind of transplant my work over here, but essentially when we're talking about choosing boys from a group of boys or choosing girls from a group of girls, the idea here is order doesn't matter. We're not choosing, like finishing a race or choosing a president or a vice president or selecting offices. So we say, consider forming a team of 12 people from 10 girls and 15 boys. The team must consist of 5 girls and 7 boys. We say, well, how many ways do exist to choose 5 girls from 10 girls if order doesn't matter? What we're going to do is this. We're going to say, well, I've got 10 total girls. I just want to choose 5. This is the way I would do it. Okay. And I say, well, how many boys exist? Well, we've got 15 total boys. I want to choose only 7 of them. Okay. So a few things that I want to say about this. We're going to evaluate both of these expressions here. But the first one is this. If I were to take the total number of girls plus the total number of boys, we should end up with the total number of people. And if I were to take these 5 girls right here and add them to these 7 boys, then we should have our 12-person committee. Okay. So here's what we're going to do. We're actually going to evaluate these now, and it's going to require a fair amount of writing. All right. So we say, well, this one would be 10 factorial over r factorial, so we got an r value of 5. And I know that this other number here in combinations, these two numbers have to add up to be the top number. So we get 5 factorial in the basement there. And then over here we get 15 factorial over 7 factorials are r, so this must be 8. So rewriting all of this, we say this is 10 times 9 times 8 times 7 times 6 times 5 factorial all over, and I'm going to write this 5 times 4 times 3 times 2 times 1 all times another 5 factorial, and I left that 5 factorial alone because I know that those are going to cancel out. So we're taking all of that times 15 times 14 times 13 times 12 times 11, 10, 9, and I can stop at 8 because I know that when I rewrite all this out, I'm going to say 7 times 6 times 5 times 4, 3 times 2 times 1, 7 factorial times 8 factorial, where this right here is going to kick out. So now we get to reduce all of this stuff here. So I'm going to take you through kind of the quick way here, but I'm looking for things to reduce that are big. So for instance, down here I say, well, 5 would cancel out with a, by 10 here. I would say, well, 5 cancels out with 10, and this would become a 2. And actually, why don't we do this? I noticed that I have a 2 down here also, so we can just knock these 2's out right now, and that would become a 1. 3 would go into 9 3 times, and we say, well, what would 4 go into? Well, 4 might go into 8. So we'd say that this would be 2. So I'm going to circle the things I have left over in this first one here that we need to multiply. And then over here, we're going to say, okay, let's start reducing things. Looks like 5 would go into 15 easily 3 times. 7 goes into 14 twice. 6 goes into 12 twice. 4 would go into what here? Now, this is kind of interesting. I say, well, 4, which is 2 and 2, I suppose I could reduce this 4 with this 2, make this 2 a 1, and make this 4 a 2. And I could reduce this 2 with this 2, make this a 1, and make this a 1 here. So we say, what does 3 go into? Well, 3 goes into 9 3 times. And this 2 here, you know, we might pass it into this 10 and we say this becomes a 5. So I'm going to circle all of these things that we have here also. And I'm not going to circle the 1s because they don't really matter that much to me. So now the only thing we have left to do is actually multiply these out. So we would say now 3 times 2 times 7 times 6 over here. 3 times 2 times 7 times 6. And we're going to take that times 3 over here times 13 times 11 times 5 times 3. And so we get a total of 1621620, 1621620 ways that we could form this committee with these people here. So one thing I will say is this. The important thing is that you're able to get it set up in the first place. But after that, in terms of calculating by hand, you can do it by hand, but we usually use a calculator to help us out with that, okay? So really quickly here, last thing it says, considering the same population as in Part A, how many different 12-member teams can be created if we must include all of the girls available, okay? So we say, well, how many girls are available? There are 10 total girls. So if I've got a 12-person team, essentially what we're saying is this, well, I got to choose girls and choose guys, and order doesn't matter. So if I have 10 total girls and I want to choose all 10, then I say, well, 10 choose 10. And then I say, okay, well, how many guys are there? Well, we said that there are 15 total guys. How many do I want to pick out? Now, if this takes some thinking, I know that I'm choosing a 12-member team. So whatever number this is right here, it's got to add up with the 10 girls we've already chosen to be 12 total people. So this had better be a 2. So go ahead and find these on a calculator. As a matter of fact, 10 choose 10, there's only one way to do that. But go ahead and find 15 choose 2, and then we'll have the total number of combinations. Cheers.